All right, today pre-algebra we are going over section 7.3. Excuse me. So, while there are many ways to solve these types of questions, we are primarily going to be looking at one method. In 7.4, I'm going to show you another method, and you can choose the one that works best for you. But we're continuing to look at ratios, and we are deciding how to simplify these ratios. So these are getting a little more complex because these ratios have fractions in them. So let's suppose that your neighbor commutes 12 miles to work and you commute 9/10 of a mile to school. If we want to write the ratio of your neighbor's commute to your commute as a fraction in simplest terms, then we need to know how to deal with the fractions here. So we have the ratio, we're going to compare our neighbor's commute to your commute. So that tells us the order. So we're going to do our neighbor's commute of 12 miles to our commute of 9/10 of a mile. I'm going to make this fraction bar bigger because that's separating the two terms of my ratio. So as I'm looking at my ratio, obviously this fraction's ugly and messy, and I want to get rid of it as quickly as possible. So the method we are going to use today, and I know you'll have other methods too, but this is the one I am showing you for today, is to get rid of a fraction. The easiest way is to multiply by the denominator, right? Because that will cross cancel. So if I'm going to multiply by 10 in my denominator to cancel the denominator of this fraction, then I also need to multiply by 10 in the numerator, because I can always multiply by 1 without changing the value. So when I multiply by 10 in the denominator, my 10s cancel here. And in my numerator, I have 12 times 10, which is 120. And in my denominator, I'm left with the 9. So now I need to simplify. So I know that 120 can be divided by 3, as well as 9 can be divided by 3. 120 divided by 3 is 40. Oops. And 9 divided by 3 is 3. So we end up with, as a fraction in simplest form, a ratio of 40 to 3 miles. So part B, then, I am looking at the ratio of my commute to my neighbor's commute. So I'm reversing the order here. So my commute, and I'm going to come over here in the margin to work so I have a little more space, 9/10 of a mile to 12 miles. I still have the same problem. I have a fraction within my ratio, so I want to get rid of it. And I have the same denominator to get rid of. So if I need to get rid of that 10, I'm going to multiply by 10. Whatever I do on the top, I have to also do on the bottom. So as I do that, those will cancel, and I'm left with 9 as the first term in my ratio, and 120 as the second term in my ratio. And again, I know that 9 and 120 can both be divided by 3, and I end up with a ratio of 3 to 40. So for every 3 miles I commute, my neighbor is going to be commuting, excuse me, 40. So my ratios are related because we would call these two ratios reciprocals. So when I take my terms and I reverse them, I'm going to get reciprocal answers. Moving on to section 2, an athlete runs on a treadmill for 3/4 hour. The athlete then lifts weights for 2 hours. write the ratio of running time to the weightlifting time. So running time is 3/4 to weightlifting time. So I have the two terms of my ratio, but I've got a fraction, so I want to get rid of it. So I'm going to multiply by my denominator. If I do that in the top, I have to do that on the bottom. Keep my fraction balanced here. So 3 times 4 divided by 4. My 4's cancel. That leaves me with 3. In my denominator, I have an 8. So I would say that the ratio would be 3 hours of running to every 8 hours of lifting weights. Easy enough. Let's double check these statements down here. We're going to check to see if they're true or false. However, this time I have a fraction as both terms of my ratio. So now I am not just trying to get rid of one fraction, I'm trying to get rid of two. So as I'm multiplying, I can't simply multiply by my denominator of each fraction anymore because I have two fractions and they don't have a common denominator. So now I'm going to multiply by the least common multiple. In other words, I'm looking for what one number I can multiply by that will cancel a 3 and a 5. So my least common multiple of 3 and 5 would be 15. So I'm going to multiply both terms of this ratio by 15. I'm going to come over here and work it out. So truly I'm doing 2/3 times 15 over 1/5 times 15. So I can cross cancel my 3 and my 15, and that becomes 2 times 5. And in my denominator, I can cross cancel 5 and 15, and that becomes 1 times 3. So now in my numerator, I have 2 times 5, which is 10, and in my denominator, 1 times 3, which is 3. So I would say true for this one. This ratio is equivalent to 10/3, and what a simpler way to say that ratio. So let's test that out in letter B. The terms of my ratio are 4/5 and 6/7. So I want to know if 4/5 to 6/7 is equivalent to 14 to 15. So as I'm looking at my two terms, I have a 5 and a 7 as my denominators. So I need to multiply by the least common multiple of 5 and 7, which of course is 35. So I'm going to work this problem off to the left here. So I'm truly doing 4/5 times 35 over 6/7 times 35. So as I work this out, my 5 and 35 will cross cancel. 35 divided by 5 is 7, so this becomes 7, this becomes 1. And down here, 7 and 35 will cross cancel. 35 divided by 7 is 1, so this becomes 5. So what I truly have in my numerator is 4 times 7, or 28. In my denominator, I have 6 times 5, which is 30. However, I see two even numbers, so these could certainly be further reduced. If I divide top and bottom by 2, I end up with 14/15, which is what I was checking to see if it was equivalent to in the first place. So this one's also true. And finally, let's check out the ratio 4/3 to 8/9. So this one's nice because 3 and 9 are different denominators, but if I multiply both of them by 9, that will cross cancel both. So I'm going to work this over here. So I'm really doing 4/3 times 9 over 8/9 times 9. And now this will cross cancel. 3 divided by 3 is 1. 9 divided by 3 is 3. And in my denominator, 9 divided by 9 is 1. So that gets really simple. In my numerator, I have 4 times 3, which is 12. In my denominator, I have 8 times 1, which is 8. But we all know 12/8 can further be reduced because they're both divisible by 4. And I end up with 3/2. So this one would not be equivalent to 2/3. They gave us the reciprocal. It would be equivalent to 3/2. All right, next thing to keep an eye out for, and we will deal with these complex ratios, complex fractions a lot more tomorrow, but I can still use my same method here of multiplying by my least common multiple or my lowest common denominator. So if I'm looking at a 4 and a 10, I could definitely multiply by 40. I could also multiply by 20, and that would cancel both of those denominators. So let's go ahead and do that. So I'm going to do 3/4 times 20 over 9/10 times 20. And now I can cross cancel. 4 divided by 4 is 1. 20 divided by 4 is 5. And in my denominator, 10 divided by 10 is 1. 20 divided by 10 is 2. So now in my numerator, I have 3 times 5, which is 15. And in my denominator, I have 9 times 2, which is 18. I see two multiples of 3 here in 15/18. So I will divide both of these by 3 and get a simplest form of 5/6. All right, the last thing to keep an eye out for is when we have ratios with different units of measurements. So if a professional football field is 53 1/3 yards wide, we want to use that information to find the ratio of the width of the actual field to the width of the field in this poster here. And we're going to write it as a fraction in simplest form. So first we need the width of the actual field, which is 55 1/3 yards, to the width of the field in the poster. And the width of the field in the poster is 1.5 feet. So a couple problems that we need to deal with. We have mixed numbers and we have different units of measurement. So I'm going to move over here and start by changing my mixed number into an improper fraction. So 3 times 50 would be 150. 3 times 5 is 15, so that should be 165 altogether. Plus 1 is 166. I'm going to keep my denominator the same, but I'm going to keep in mind that this is yards. So I know that there are 3 feet in a yard. So for every yard, I am going to multiply by 3 feet to a yard. And when I do that, I can cross cancel and realize that this is 166 feet. So I'm going to take this amount and I'm going to substitute it into my ratio here so that I can compare feet to feet. Now I do need to also convert this mixed number into an improper fraction. So this, excuse me, becomes 3/2. So my ratio is going to be 166 feet to 3/2 of a foot. So I have a fraction that's icky. I want to get rid of it, so I multiply by the denominator. If I multiply by 2 on the bottom of my ratio, I have to also do that on the top to keep it balanced, because I can always multiply by 2 over 2 because that is an overall value of 1. So when I double 166, and my 2's cancel, so I have 332 divided by 3. And I'm going to run out of time. So that reduces to 1